Good morning. We are starting our last unit of the year. We are starting with CO72. I can determine the number of possible outcomes of an event. So what does that mean? Possible outcomes are a list of all the resulting possibilities from an event. So an event is the thing that we're doing. So flipping a coin is an event. You flip that coin 3 times, how many events is that? If flipping the coin is an event, if we flip the coin 3 times, how many events? Show me with your fingers. How many events would that be? Some of us are like, 3? Yeah, it's really that easy. Okay. Everything that you're doing is the event. We need to know how many events are happening. So if you flip a coin 3 times, that's 3 events. You roll the dice 2 times, that's 2 events. You flip a coin and then roll a dice, that's 2 events. So every action that you're doing is an event. So we want to know, if we flip that coin 3 times, how many possible outcomes are there? So first thing we're going to do is looking at the probability tree. Once we look at how the probability tree works, then we're going to look at how the counting principle works. When we would use one versus the other. So when we use the probability tree, we're going to write our first event, flip 1. So I've got my coin. How many outcomes can happen when you flip that quarter? What could you get as an outcome? Claire?
Heads.
You could get heads. What other outcome could you get? Jack?
Tails.
Tails, right? There are 2 outcomes when you flip a coin. There's 2 sides to a coin. You could get heads or you could get tails. Now, we want to flip that coin 3 times. So we have flip 2. If I flipped heads first, what outcomes could I get on my second flip? Michael?
Heads.
I could get heads. What other outcome could I get? Fernanda?
Tails.
Tails. What if I flipped a tails the first time? Now I want to flip my coin again. What are my possible outcomes for my second flip? Rhoda?
Heads.
And?
Tails.
Yeah. Now I need to do my third flip. So if I flipped my heads the first time, and then I flipped heads the second time, now I'm flipping it a third time, my possible outcomes, heads or tails. That's an H. Then if I flipped heads, flipped tails, my third flip, I could get heads or tails. If I flipped tails and then I flipped to heads, I could get heads or tails. And if I flipped tails, third flip, I could get heads or tails. So I have 3 events because I had 3 flips, 3 actions I was doing. I can now write down all of my outcomes. So I'm going to follow it through. I could get heads, heads, heads. I could get heads, heads, tails. Then I could get heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. How many outcomes is that? Total possible outcomes. How many did we list? So count them up. How many outcomes do I have listed, Presley? 8. So when it says how many possible outcomes are there are 8 possible outcomes. And we can see what each of those possible outcomes would be. Flipping that coin, how many times could I do a heads, heads, tails? Okay, so we need to be able to figure out how many possible outcomes, and we use that probability tree when we want to see all of those. Now let's do the probability tree with our articles of clothing. We have 3 pairs of pants and 4 shirts. How many possible outfits can you make? How many events do we have happening here? Rhoda?
7.
I like how Rhoda was thinking, oh, we need to add them all up. But remember, these are like the heads and the tails, right? What colors of shirts, what colors of pants? We need to look at the action that we're taking. I'm picking a shirt, I'm picking a pair of pants. How many events is it that I'm doing the action on, Jack?
2.
2 events. I'm picking pants, I'm picking shirts. So I have 2 events. We've got pants and we've got shirts. The choices that we can get for pants and shirts is not what makes up the events. Does that make sense? So we need to come up with some colors. What color pants do you think we could have to choose from? Claire, give me a color.
Gray.
Vinny.
Blue.
Jackson.
Black.
And one more pants color. Moses.
Pink. Pink.
Yes. Nice and bright color. All right, now we need how many shirt colors?
3.
3. No. Oh, I did that wrong. 3 pairs of pants. So we're going to move that pink to a shirt. So I need 4 shirt colors, so 3 more colors. Claire.
Yellow.
Michael.
Purple. Purple. Purple.
And Haley.
Green.
All right. So just like when we flipped a coin, we could have heads or tails. When we pick pants, we could have gray, blue, or black. When we pick shirts, we could have pink, yellow, purple, or green. So we're going to start off with our first event, picking a color of pants. So we're going to have gray, blue, and black. Then we have 4 colors of shirts that we could match up with each color of pants. So if we pick gray pants, we could have pink, yellow, or purple, or green. We pick blue, we could have pink, yellow, purple, or green. And if we pick black, we could have pink, yellow, purple, or green. I'm shortening it with just that first letter or 2 so we know the colors. Because it's Monday and I don't want to write out my colors all the way, but you sure can if you want to. My Monday, I don't want to. Now, we need to figure out how many outcomes that is. We could have gray and pink, We could have gray and yellow, gray and purple, gray and green. We could have blue and pink, blue and yellow, blue and purple, blue and green. We could have black and pink, black and yellow, black and purple, black and green. So how many outcomes could we have altogether? How many possible outfits could we have? If we could have a gray and pink, we could have a blue and pink, we could have the black and pink. How many different outcomes are there listed? Joy? Not 13. You should be able to count on your paper. If you're having a hard time seeing the screen, you should have it all written out on your paper. Count them on your paper. So if you didn't list them all out, list them all out. Chandrea, there are 12. So we had 4 grays pants, 4 blue pants, 4 black pants with the different colored shirts that go with them. We would use the count or the probability tree if we want to know, like, how many outcomes with a pink shirt. We could look easily and say, okay, there's 1 pink shirt, another pink shirt, and another pink shirt. 3 of those 12 outcomes would have a pink shirt. For this objective, we're going to look at the counting principle and focus just on total number of outcomes, not individual outcomes, like how many had a pink shirt. We're going to want to know how many outcomes altogether could we get. So I'm going to show you an easier way of figuring that out rather than listing every single outcome. So the counting principle, we have to list our events. So if we go back to that coin flip, how many events did we have with our coin flip? Who remembers? How many events did you list for the probability tree? Chandrea? Not outcomes, events. How many events did we have? How many actions did we do? 3. We had flip 1, flip 2, and flip 3. So we have our 3 events, and then we have down here, we're going to label this number of outcomes. So I flip my coin once. How many possible outcomes was there for 1 flip? Claire? 2. Heads or tails? Flip 2. How many possible outcomes are there when I flip it a second time, Matt?
2.
And flip 3. How many possible outcomes are there when I flip it that 3rd time, Jack? 2. So I have 2 outcomes for my first flip, 2 outcomes for my second flip, 2 outcomes for that 3rd flip. Heads or tails, heads or tails, heads or tails. Now, once I list, first step is listing your events. Second step is listing how many outcomes for each event. Third step, we take all of those possible outcomes and we multiply across. What is 2 times 2 times 2? Claire?
6.
Not add. 2 times 2 is 4. 4 times 2 is
8.
yes, you kept adding in your head. You were saying times, but it is so easy to accidentally add them. 2 times 2 is 4. 4 times 2 is 8. How many possible outcomes did we have for the probability tree? 8, right? We listed them all out for the probability tree, but the counting principle, we're just finding total outcomes. Okay. Let's look at our outfits. How many events do we have for our outfits? So look at the probability tree. What events did we put for our probability tree? We're going to want to put those same events for the counting principle. Joy? There are 2 events. What are they, Joy? We've got pants and we've got shirts. And then over here we say number of outcomes. How many possible outcomes are there with the pants? Benny?
Oh, okay.
I know. How many possible outcomes do you think there would be with pants? We have 3 pairs of pants.
Right?
Yeah, 3 possible outcomes. It could be gray, it could be blue, it could be black. 3 possible outcomes. How many possible outcomes with the shirts, Leo? 4. It could be pink, it could be yellow, it could be purple, it could be green. Now that I've filled in the table for the counting principle, what math do I do? Audrey?
3 times 4.
Yeah, I multiply all those outcomes. What is 3 times 4, Audrey?
12.
12. And look, I had 12 with the probability tree, 12 with the counting principle. So if you just want to know total outcomes, you can use that counting principle. Here's the trick. You need to list each of the events and think about how many outcomes there are in each event. I list pants, there are 3 different pants, so I put a 3 for the outcomes. There are 4 different shirts, so my outcomes for the shirts are 4. Is that making sense? We need to remember that we are multiplying those. So, let's look at the bottom. Using either method, determine the possible number of outcomes. You're going to show your work. You're going to flip a coin twice, and you're going to roll a 6-sided die. Do we want to do the probability tree or the counting principle? Matt? Counting principle is easier. You could do the probability tree definitely and list them all out. It just takes a little longer. For ease of, yeah, it's a Monday and it's the end of the school year, we want to do the easy route. How about we do the counting principle together? So, what's my first step? Put it up on my, what's the first step that I have to do? Matt? I have to make the table. What's the first part of the table I'm going to fill in? Joy? Okay. What am I going to put? Joy? Okay, I need to put my events. How many events do I have happening? Really look at that. How many actions am I doing? How many events are there? Be careful looking at it. Everybody look and count. How many events do you think it is? Show me with your fingers. How many events do you think it is? Hold it up top. Ooh, I see some 2s and I see some 3s. What 2 events did you have? Claire, did you have a 2 up? What 2 events do you have? We're flipping a coin, we're rolling a dice. So why did some of us put up 3 fingers? Because we have 2 things, we have coins and we have dice. Why did we have 3 fingers up, Charlotte? We're flipping that coin 2 times. So we need to list each one separate. So we have flip 1, we have flip 2, and then we have our roll. So we can't just count coin and dice, we have to count how many actions we're doing. Flip one, flip two, and then the roll. So now, we're gonna put number of outcomes for each action. Flip one. How many outcomes are there when we flip a coin, Fernanda? 2 outcomes, heads or tails. Flip two. How many outcomes are there, Vinny? 2, heads or tails. We're gonna roll a 6-sided dice. How many outcomes when we roll a dice? Moses. It's a 6-sided dice. How many possible outcomes are there? So I could roll that dice and it could be a 1. I could roll that dice and it could be a 2. 6 outcomes, because there are 6 sides. It could land on any of those sides. What do I do now? How many possible outcomes are there? What do you think? Michael,
24.
how did you get 24, Michael?
2 times 2 times 6.
2 times 2 is 4. 4 times 6 is 24. Bam. 24 possible outcomes. So be careful. It is super, super common for people to look at this problem and say, well, there's 2 events, coin flip and dice roll. About half the class said 2 events. That's common. But the other half took it a step farther. Wait a minute. How many times am I flipping that coin? How many times am I rolling the dice? You have to write every single action is an event. List them all separately. Okay? Super important. Let's look at our homework page. Using either method, determine the possible number of outcomes. Show your work. So if you are doing the counting principle, I want to see your table. I want to see it labeled. I want you listing every event and how many outcomes for each event. I want you putting what operation you're doing to get your answer. I put my multiplication dot where I'm multiplying. That's going to help us next week when we are getting ready for our test, remembering what math we're doing. So let's look at the first one together. A pizzeria has 4 types of crust, 15 toppings, and 5 pizza sizes. How many one-topping pizzas can be ordered? How many events is that? Show me with your fingers. How many events? We have 4 types of crust, 15 toppings, and 5 pizza sizes. Show me your fingers. How many events? I don't know. Show me your fingers. How many events could it be? 1 hand, 2 hands, 1 hand? I see lots of people with no hands up.
Yes.
How many events? What actions are we doing? What are we choosing? What are we choosing from? Evelyn, give me one of our event choices. We have 4 types of crust, 15 toppings, and 5 pizza sizes. What's one of the choices I have to make? Toppings. That's an event. Knowing that toppings is an event. Show me your fingers. How many total events do we have altogether? 4 types of crust, 15 toppings, 5 pizza sizes. How many events would that be? I should see 3 fingers up. We know one of our events is our toppings. What's another event? Jude?
The types of crust.
Types of crust. What's another event? Leo?
The sizes.
The sizes. Now we have to put number of outcomes for each event. How many outcomes are there for choosing the crust? Rhoda,
4.
how many outcomes are there for choosing toppings? One topping. Fernanda,
15.
how many outcomes are there for choosing a size? Audrey,
5.
what is my final answer? How many outcomes are there? All together, how many outcomes do we have? Yep, you're gonna want your calculator. Andrea. Okay, good catch. Go back and multiply. Haley, 300. How did you get 300, Haley? That seems like a lot of outcomes. How did you get that? Multiplied them all together. What really spikes it up is that 15 different toppings to choose from. 4 times 15 times 5 gives us 300 different pizza outcomes. Michael.
Imagine doing that with the tree.
Yes. Imagine doing that with the tree. This is why we do the counting principle, to make it simple and easy. If we just need to know total outcomes, counting principle is way easier when you have like something like 15 outcomes for only one event. Okay? You are going to do this for the rest of the page. Make your table. Really think about what your events are. What are the actions that you are doing? Every action is an event. I'm picking my crust. I'm picking my topping. I'm picking my size of the pizza. Each choice, each action is an event. Please stop. Figure out how many outcomes there are for each event. Multiply them all together. Don't forget to put that you're multiplying. So we can catch it when we accidentally add. We go, oh, wait a minute, I was supposed to multiply. Multiply, multiply, multiply. Final answer is how many total events there are. Any questions? Okay, go ahead and get to work. If you want to check your answers, bring it on up, and we can check answers. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.